So basically today we're going to talk about the frequency response analysis. Frequency response analysis technique is a kind of fantastic and advanced technique which is completely non-destructive, and that one is going to be used for winding deformation detection inside the transformer or inside the motor and generator. So if you look at the device, this is a typical device which is measuring the frequency response. It is sweeping from 20 Hz up to 2 MHz. So basically the sinusoidal signal over the transformer winding. So you need to connect actually the input signal, which is the yellow wire, so to the input or to the lead wires or to the input terminal of the transformer winding, and you can get the response, which is the blue one, so from the end of the winding. In the meantime, the red wire provides you the information and is taking sample from the voltage level in the input terminal. So when you conduct the tests, so you will get such a kind of graph over your software. So if you look into the software, so you will get basically from 20 Hz up to 2 MHz a kind of a spectrum, which each and every part of the spectrum is providing you some information so about the characteristic of your transformer active part. When I'm saying active part, I mean transformer winding and transformer core. So there are different kind of the techniques which you can evaluate the transformer FRA signature or any other frequency response signature. So, and those techniques going to be statistical indicators, or these days recently we are using machine learning and different kind of advanced technique to evaluate and automate the evaluation or the analysis of the signal. So it's very actually effective test. It can provide you the information about the structure of your winding without opening actually your test object. So you need just to have access to the terminal of your test object, and simply you can do the measurement. Any kind of deviation, any kind of deformation, any kind of defect inside of your object or in your winding, so it can change some kind of basically deviation, so or can cause some kind of deviation in the FRA spectrum. Therefore, if you are getting deviated signal from the original signal, which is this signature, you can become suspicious that probably that winding has got deformed. If you're moving a little bit further, so basically in this lab, so we have got actually RLC meter, which this RLC meter is able to measure in different frequency range. It is able to measure R and L and C, of course, parameters, which they are fundamental parameters, and we regularly using actually this RLC meter to measure our winding parameters. So the advantage of this equipment is to increase the frequency, and basically in different frequency range, it's providing different kind of values for us, the real value of your component. So in the meantime, we have got here the programmable power source, which you can program whatever you want. You can program, for instance, sinusoidal signal, harmonics, and basically third harmonics, fifth harmonic, and any other harmonics. So of course that one is a power source. So moving to here, we have got the modeling of the power lines, so which we can actually teach our student using that basically block. So we have got power analyzer, which we can analyze the quality of the power. So for instance, in this specific experiment, we are analyzing and we are evaluating the quality of the current, which is flowing through the incandescent, through the compact fluorescent lamp, through the fluorescent lamp, through the LED lamp. So we can evaluate all of these signal using the power quality analyzer. Power quality analyzer is providing information up to the harmonic number 50, which the frequency is going to become, if we suppose that the frequency, fundamental frequency is 50 Hz, the frequency of the measurement is going to be up to 2,500 Hz, which is quite enough if we're going to actually, perform analysis over the power quality. So moving forward, of course, here we have got very high frequency oscilloscope, so which this oscilloscope is able, to analyze the data, so to save, record, actually send the information. So the operating system is Windows, and basically that one is quite fantastic. So here you will find one of our products, so at Nazarbayev University, which this product is a smart monitoring system, which this smart monitoring system basically can grab the information from your feeder. The feeder can be the feeder of the transformer, the feeder in your substation, the feeder entrance to the building, or any kind of the feeder. So it can grab the information actually from the feeder, so using this clamping ammeter, and then basically it is bringing information over this device and sending this information to the cloud, and using the cloud, it is analyzing the data and sending the information to your mobile phone application. So we have developed a kind of mobile application. So in the Android, which you can simply access to your application, connect to the feeder and see and check and see that what is going inside the feeder. So getting a little bit further, you can find 20 kilovolt circuit breaker. So which we have got this one from the industry. So and if you look at here, so we are teaching our students so in different component wiring and everything about the circuit breaker. So we are also giving the lecture, so an experiment for our student over the relays, different kind of the relays we have got here, so differential relays, so and overcurrent relay, and different kind of the relays is going to be tested. So this is CPC100, which is really fantastic equipment, which can measure 13 or 14 different, tests and different kind of the evaluation over power component and power test object. So there is a CPC100, which is the name of this guy, and there is a CPTD1, which that guy can increase the voltage up to 12 kilo. So here we have got the insulator, of course, with the coronary, which we are teaching our student. So in terms of the coronary, in terms of the potential distribution, so basically at the terminals of the insulators and in the high voltage level. So we have got different kind of, outdoor insulators for teaching. So the ceramic insulator, glass insulator, so a student can actually, basically look at them, test them, and just, evaluate them personally. So we are using UAV, so because we are working on a specific technique, so we are using UAV, so to monitor the outdoor insulator. If you look at actually to this photo, so there is a camera over the UAV. Using this camera, when the UAV is just flying, it can go and just turn around the insulator in the overhead lines, and it's capturing different kind of the dynamic images, and then getting that image using image processing and machine learning, we are analyzing the surface and the quality of the surface of the insulator. So we have got one more equipment. So this is a 40 kVA transformer. This is an oil field transformer, which we are teaching to our student different compartment of the oil field transformer, and of course we are testing this one with different kind of equipment, including CPC100, FRA, and the other kind. So we have one more equipment. This is dry torque transformer, because we are comparing our oil field transformer result with the dry torque, and of course we are talking about the structure of different kind of the component. So composite insulator is available. So now this is the basically circuit breaker, 20 kilovolt circuit breaker, which we are teaching different part of the circuit breaker to our students. So to give the voltage to our components, so we have got auto transformer, which a student can step by step increase the voltage. So each auto transformer is supporting 3-phase. And the power rate of each auto transformer is 20 kilovolt ampere. So therefore we can simply energize our test object, except that 40 kilovolt ampere transformer, which we are not usually energizing that one. We just do the test over that one using different kind of equipment. Here different range of the transformer are available, and we are teaching and doing the research, of course, over these different kind of the test objects. And our students are getting familiar with different size, different active part, different winding type of a transformer, and we are evaluating actually different transformer ranges or level. So, and of course in this lab, so we are trying to do our best, and this is one of those labs which we have been developed for Nazarbayev University, and we do believe that so our student can get the fundamental training before joining to the industry. Thank you very much.